Boiling points of hydrogen halides. This is today's lesson. In this lesson, we are going to learn unusual trend of boiling points of hydrogen halides. So let's begin. Boiling points of hydrogen halides. We know that halogens belong to column 17 in the periodic table. Fluorine, chlorine, bromine, iodine, astatine, and tennessine. Astatine and tennessine are radioactive elements. That is why these two elements are kept out of consideration. Now let us see atomic sizes of these halogens. We know fluorine is smallest in size. Then atomic size increases from top to bottom in this way. Iodine is biggest in size and fluorine is smallest in size in this column. That is, atomic size increases from top to bottom. Now let us see hydrogen halides. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. Hydrogen fluoride is liquid at room temperature, but other halides are gaseous in physical state. This is question number 1. Why? Why this is liquid in state, but other halogens are gaseous in state? Number 2. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. Boiling point of hydrogen fluoride is 19.5 degrees Celsius. Boiling point of hydrogen chloride is minus 85.05 degrees Celsius. And boiling point for hydrogen bromide is minus 66.8 degrees Celsius. And this is for hydrogen iodide is minus 35.36 degrees Celsius. That is, from hydrogen fluoride to hydrogen chloride, boiling points decrease. But from hydrogen chloride to hydrogen iodide, boiling points increase. Unusual trend in the boiling points of hydrogen halide. From hydrogen fluoride to hydrogen chloride, it decreases, and from hydrogen chloride to hydrogen iodide, it increases. That is, order of boiling points is firstly hydrogen fluoride, then unusually hydrogen iodide comes. After that, hydrogen bromide, and finally hydrogen chloride. Why this unusual trend in the boiling points of hydrogen halides? This is what we are going to learn today. So let's go to the detail. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen halides. Simple expression is this: hydrogen halides Here, electronegativity of fluorine is 4.0 and this is 2.1 for hydrogen. Electronegativity of chlorine is 3.0, 2.1, 2.1, this is 2.8. Electronegativity of iodine is 2.5 and this is 2.1 for hydrogen. Actually, this title involves 2 points. One is strength of hydrogen bond. Boiling points of hydrogen halides involves strength of hydrogen bond. Number two, it involves van der Waals force. Intermolecular van der Waals attraction force. Another point, strength of hydrogen bond involves electronegativity. Now let us see why this is liquid at room temperature and why these halides are gaseous in state at room temperature. We learned that this title involves strength of hydrogen bond. Here, electronegativity difference between hydrogen and fluorine is very high compared to other hydrogen halides. That is why here covalently bonded electrons move towards fluorine. Fluorine becomes negative in charge. Hydrogen becomes positive in charge. As electronegativity difference is very high, so in this case, negative charge density becomes higher, positive charge density becomes higher. Another hydrogen fluoride molecule, negative charge density becomes very high and positive charge density becomes very high. So the hydrogen bond between two molecules of hydrogen fluoride becomes stronger because of the high difference in electronegativities between hydrogen and fluorine. The hydrogen bond formed among the hydrogen fluoride molecules becomes stronger. That is why hydrogen fluoride turns into liquid. Hydrogen fluoride remains as liquid at room temperature because of this stronger hydrogen bond. But in case of chlorine, that is in case of hydrogen chloride, in case of hydrogen bromide, and in case of hydrogen iodide, electronegativity difference decreases. Electronegativity difference decreases from chlorine to iodine, that is from hydrogen chloride to hydrogen iodide according to strength of hydrogen bond. Boiling point is supposed to decrease according to strength of hydrogen bond. Boiling points is supposed to decrease from hydrogen chloride to hydrogen iodide. Actually, from hydrogen fluoride to hydrogen iodide, this is supposed to decrease according to strength of hydrogen bond, because strength of hydrogen bond decreases from hydrogen fluoride to hydrogen iodide as electronegativity difference decreases. But in case of hydrogen chloride to hydrogen iodide, molecular size increases. Actually, for hydrogen fluoride, hydrogen bond plays dominating role. For hydrogen fluoride, hydrogen bond plays dominating role. That is why hydrogen fluoride becomes liquid at room temperature and its boiling point is 19.5 degrees Celsius. But for hydrogen chloride to hydrogen iodide, not hydrogen bond, rather van der Waals attraction force plays dominating role. Van der Waals attraction force plays dominating role for hydrogen chloride to hydrogen iodide. That is why intermolecular attraction force increases for hydrogen iodide. We know intermolecular attraction force increases with the increase of molecular size. That is why hydrogen iodide, its boiling point is comparatively higher than hydrogen bromide and hydrogen chloride, because in this case van der Waals attraction force plays a dominating role, not hydrogen bonding. Finally, considering van der Waals attraction force and strength of hydrogen bond, order of boiling points, that is, firstly hydrogen fluoride will come, considering strength of hydrogen bond. In case of hydrogen fluoride, stronger hydrogen bond is formed. That is why it becomes liquid at room temperature. Then hydrogen iodide comes. In this case, not hydrogen bonding, van der Waals attraction force plays the dominating role because of this higher molecular size. After that, hydrogen bromide comes, and finally hydrogen chloride comes. This is unusual trend in the boiling points of hydrogen halides, and for the same reason hydrogen fluoride is liquid at room temperature and other hydrogen halides are gaseous in physical state at room temperature. This is all about boiling points of hydrogen halides. No more today. Thank you very much.